To finish up our unit on solving systems, we're going to take a quick look at some special cases before working through some problem solving or word problems so that you can get some practice with setting up a system given a problem, a real world example problem. But first, let's take a look at these special cases. So now some systems, when you look at them, you have to decide whether to use substitution or elimination. Now that you know both processes, you can make those decisions. So for this first one, we have y equals 4x plus 1 and 8x minus 2y equals negative 2. And this system is set up really well for substitution because we have one equation that's already solved for one of the variables. So I'm going to use substitution here. I'm going to plug in this 4x plus 1 into the other equation for y, because it does say y equals 4x plus 1. So that'll be 8x minus 2 times 4x plus 1 equals negative 2. And then to distribute and solve, we will get 8x minus 8x minus 2 equals negative 2. And then I can combine like terms, so that's 0. These actually cancel out. So we're left with negative 2 equals negative 2. And that is true. And so remember, when all your variables cancel out and what you're left with is a true statement, this means that no matter what value you put in for x, you will get, it'll make the equation true. So no matter what point you pick here, as long as it's on one of those lines, it will be a solution to the system. So this is where we have infinite solutions. And what that means for a system, remember back in graphing, it means that these two equations are actually the same equation and they graph the same line. And so they intersect infinitely. Let's look at number 2. Again, set up for substitution, we've got x equals 2y, so I'm going to take that 2y and put it right here for x in the other equation. So 2 times 2y minus 4y equals negative 10. And when you multiply there, 2 times 2y is 4y minus 4y equals negative 10. And again, we can combine like terms right here. 4y minus 4y is 0 equals negative 10. And now we see we have a situation where our variables canceled out, but what's left is not a true statement. And what that means is no matter what numbers you put in for x and y, nothing will make the equation true. And remembering back to graphing, that means that these two equations are parallel, and so they'd never intersect, which means there is no solution here. So you can get no solution and infinite solution when you solve a system algebraically as well as graphing. You just need to remember what it means for the graph. Either they intersect infinitely and are the same line, or they don't intersect at all. Let's take a look at 3 and 4. Now looking at number 3, it looks like it's set up really well for elimination because we have two equations, they're both in standard form, and our terms are lined up. And in fact, we already have opposites on our x's and y's. So when you add these together, 2x minus 2x, that's 0. 5y plus negative 5y, also 0. And it equals negative 10 plus 5 is negative 5. Here's another situation where you have a statement that's not true. And this is, again, no solution. Because if you graphed these equations, they would be parallel but would not intersect. One more here. Looks like, again, set up pretty well for elimination. Let's multiply this equation by 2, however. So that will be 2x minus 6y equals 12. And if you look at those equations, they are exactly the same. Let's go ahead and make one of them negative, which I should have done in the first place. So let's change that to negative 2x, positive 6y, negative 12. And when you add those together, the 2x's cancel out, the negative 6y cancels out the positive 6y. The 12's cancel out as well, they're also opposites, so 0 equals 0. And this, again, is a true statement, so we have infinite solutions. As soon as we saw that our two equations were exactly the same, we could know that that's infinite because, again, if you have two equations that are the same, they will graph on the same line, which means they intersect infinitely on the graph. So there's some special cases there. It can still happen when you're solving algebraically with substitution or elimination. So just something to keep in mind as we continue to practice solving systems of equations. Now let's get into the word problems. Here are the steps you want to take when you are reading through and solving these problems. First, and really important, define your variables. So what that means is indicate somehow, write down what x and what y equal, or whatever letters you're using, what they equal in words, so that you know what they stand for as you work through the problem. Next, you're going to set up two equations using the information in the problem. So you're going to write a system of equations, and usually you can tell in the problem what the two equations are. Sometimes it's a little more challenging though. And then we solve the system using any of the methods we know, substitution or elimination. And then we're going to write the answer to our question in words so that our answer makes sense in the context of the problem. So let's try it. Number 1 says 3 times one number added to twice another number is 23. 4 times the first number added to twice the second number is 12. Find the two numbers. Remember, the last part of a word problem tells you what your variables are going to stand for. This one's pretty straightforward. Our numbers are going to be our variables are going to stand for the two numbers. So let's go ahead and make, so this one says the first number and the second number. Let's make x the first number, and let's make y the second number. Maybe I should write that out. Number. So now we have to write our two equations. And if you look, they're kind of written out for us. 3 times one number added to twice another number is 23. And then for the second equation, 4 times the first number added to twice the second number is 12. So just try to remember what words mean what symbols or numbers in an equation, and we can write that out. So for the green one, 3 times one number, well, that'll be 3x, added to twice another number, that's plus 2y, is or equals 23. And then for the second equation, 4 times the first number, well, that's 4x, added to twice the second number is 12, so equals 12. So there we have our system. So just write down, for this type of problem, exactly what you're told to. Now we have to solve this system using elimination or substitution. Looks like it's set up pretty well for elimination. I'll just multiply this first equation by -1. I'll go ahead and just add negatives in here. And then we'll add these two equations together. We end up with 1x, the y's cancel, equals 11, -11. So there's our first answer, x equals -11. And then we have our substitution step. We're going to plug -11 into one of those first equations. So 3 times -11 plus 2y equals 23. So that's -33 plus 2y equals 23. We'll have to solve here by adding 33. So 2y equals 56. And then dividing by 2 gives us y is equal to 28. So the two numbers are -11 and 28. And there's our solution. So read through the problem, write a system, and then solve the system. Let's look at example 2. 2 lengths of rope add to equal 180 feet. The measure of rope X is 10 feet longer than 3 times rope Y. Find the measure of each rope. Well, there is what our variables are going to stand for. And in fact, it tells us we have rope X and rope Y. So we don't really need to define those. They're defined for us as rope X and rope Y. But let's figure out our equations. 2 lengths of rope add to equal 180. And the measure of rope X is 10 feet longer than 3 times rope Y. So let's write that out. 2 lengths of rope add to equal 180. That's X plus Y. Those are our 2 rope lengths, and they equal 180. 2 lengths of rope add to equal 180. Now for the green equation, the measure of rope X is, so X equals 10 feet longer than 3 times rope Y. So 3Y plus 10, or 10 plus 3Y. And there's your system. Now we're going to use substitution here because it's already solved for X. So we'll take this expression and plug it in right here for X. So 3Y plus 10 plus Y equals 180. And then we can combine some like terms here. 3Y plus Y, that's 4Y plus 10 equals 180. We'll keep solving by subtracting 10. So 4Y equals 170. And then divide by 4. And so Y here equals 170 divided by 4. That's 42.5. So there's the length of one of our ropes. Now we know that X plus Y equals 180 from our first equation there. So X plus 42.5 equals 180. And we've got to subtract 42.5 from 180. So X is going to equal 180 minus 42.5, just to make sure we get it right, 137.5. So there are our 2 lengths of rope. And because they're set up as rope X and rope Y, we can say X equals 137.5 feet and Y equals 42.5 feet. Let's keep going. Number 3, Nathan is older than Stephen. The difference in their ages is 12, and the sum of their ages is 50. Find the age of each. Just to make things easy here, let's make N Nathan's age and S Stephen's age. Now let's set up our system. Let's move this out to the side here. So the difference in their ages is 12. That's one equation. The sum of their ages is 50. There's another one. Let's set this up. So the green, or the blue equation, the difference in their ages. Well, difference means subtraction. And we know that Nathan is older, so that should go first. N minus S equals 12. And then the sum of their ages, well, that's plus N plus S equals 50. Now let's solve the system. We can see this is set up already really nicely for elimination. Let's go ahead and add here. So the S's cancel. We get 2N equals 62. Divide by 2. And N equals 31. So we know that Nathan is 31. Now we're going to plug that into that first equation. N minus S, well actually let's do the second one, N plus S equals 50. Then we won't have to divide by -1. So 31 plus S equals 50. And now just subtract 31. So S equals 19. So now we know both. So we know that Nathan is 31 years old. And we know that Stephen is 19 years old. Okay, number 4. Old Navy's having a sale on tops and jeans. Lauren bought 2 tops and 3 pairs of jeans for $51. Sam bought 3 tops and 1 pair of jeans for $31. what's the sale prices on the tops and jeans. So we know that our variables stand for the prices of those things. Let's go ahead and make it easy. So let's say T can be the tops, the price of the tops, and then let's make J the price of jeans. So let's make the system. Lauren, let's have an equation for Lauren. Lauren bought 2 tops and 3 pairs of jeans for $51. So that's an equation right there. 2 tops would be 2T plus also her 3 pairs of jeans, and that's going to total $51. For Sam here, he bought 3 tops and 1 pair of jeans for $31. So that will be 3T plus 1J, and that equals $31. And now we need to solve the system. Honestly, it might be the same amount of work here to do substitution or elimination, because we're either multiplying the second equation by -3 or solving for J by subtracting 3T. And I might actually do that. So I know that J is going to equal 31 minus 3T, because I just subtract 3T there. So now I'm going to plug that in here for J. So 2T equals 3 times 31 minus 3T equals 51. That needs to be a plus. So 2T plus 93 minus 9T equals 51. They're running out of space here. So combining like terms, that's -7T plus 93 equals 51. We'll subtract 93, so -7T equals, that's -42. I'm really running out of space. I'll move that up here. I'll scoot these over here. Okay, to finish solving this, we just need to divide by -7. And so T equals 6. Now we'll just plug that into this equation here that we solved for J. So J equals 31 minus, and 3 times 6 is 18. So J is going to equal 13. And there we have our 2 prices. So tops here we know are $6, and jeans we found to be $13. Let's keep it going. Number 5, a high-risk stock pays dividends at a rate of 14% per year, and a savings account pays 4% interest per year. How much of a $5,000 investment should be put in the stock, and how much should be put into savings to obtain a return of 10% per year on the total investment? Kind of tricky here. So let's break this down. We want to know how much of each thing. That's what our variables stand for. So let's make X the amount of the 14% stock, and Y the amount of the 4% stock. So that's what X and Y will stand for. Now our 2 equations, we know that the total is $5,000. That's how much these are going to total up. So that's going to be X plus Y equals 5,000. For the second equation, we know that one pays dividends at 14%, one pays 4%, and we want 10% on the total. So here's how that's going to look. Just write the same equation, but put the percentage in front of the number. And we could use the decimal, but since they're all the same percentage per year, we can leave the decimal off. So we're going to have 14x, that's 14% for the x one, for y, and then we want 10% on the total, so that's 10 times 5,000. Which is just 50,000. So 10 times 5,000. Okay, so now we just solved this one. I'm going to go ahead and use elimination here, so I'll just change these. But we need to multiply, actually. So we're going to multiply this equation by -4. So we have -4x minus 4y equals -20,000. And when you add those together, we get 10x. The y's cancel, and it equals 30,000. And then just divide to find x. 30,000 divided by 10 is 3,000. Not too bad. Now we have to find y. We know that x plus y equals 5,000. So we're going to put 3,000 in for x. And then subtracting 3,000, we get y is equal to 2,000. So kind of a complicated problem, but the system's not too bad to solve. So we have $3,000 at our 14% rate and $2,000 at 4%. Okay, one more problem. Jamie has 38 coins. Some are nickels, some are pennies. The total value is 90 cents. Find how many of each coin she has. So we need to know how many of each coin. So let's make n the number of nickels. And let's make p the number of pennies. Okay, now for our first equation, Jamie has 38 coins. That's going to be n plus p equals 38, because the number of each coin adds up to 38. And some are nickels and some are pennies. We know that. The total value is 90 cents. Very similar to the one we just did. Let's set that up as 5n, because those are 5 cents each. 1p, because that's 1 cent each. And then we know the total value is 90 cents. So we can just write, if we take the decimal off and just use 90, we don't have to worry about 0.05 or 0.01. Let's do elimination. Let's make that negative there. So your second equation, that 5n plus p, that applies the value of each coin to the variable. So 5n, 1p, because pennies are 1 cent each, adds up to 90 cents. Add here, we get 4n equals 52. Divide by 4, and we know that n is equal to 13. So there are 13 nickels. We also know that n plus p equals 38. So 13 plus p, because n is 13, equals 38. We'll subtract 13, and we get p is equal to 25. So we know that there are 25 pennies and 13 nickels. There you have it. Read through the problem, write a system, define your variables first, then write a system, and then solve it.